Now, unfortunately, things tend to get longer. The more we go, we had one step, we have two steps, and now they're saying general, which means they're going to start throwing more than just two steps at us. Okay, but again, the whole idea is you work from the outside, peeling off the layers, and get closer and closer to the x so that finally you get the x by itself. Okay, and I'm going to keep talking about that pretty much every time. So again, we solve kind of backwards because it is the reverse of the order of operations, because you're peeling off those layers because those are stuck together, and so you have to get rid of the outside stuff first. All right. Oh, we've got three things this time to get rid of. Here is our boundary. What three things are we going to get rid of?
2x and a -6.
A 4, a 2, and a -6, right? Those are the three numbers we got to get rid of. Now, I'm going to ask you, what's the very, very inside layer? What's grouped directly with the x?
2.
The 2. Okay, so this is my very, very inside layer. What's my next layer? What's grouped with the 2x?
4. -6.
The -6 is in the parentheses, right? That groups it together. Does that make sense? Because the parentheses group it. So let me use green. So the next layer is that. So the first thing we have to get rid of is the outside. That's the 4. Okay, now who can tell me? Again, they're getting longer, I understand. Who can tell me how we get rid of the 4?
-4.
No,
Okay.
No.
division.
Okay,
Divided
you're
by
right.
4.
This is 4 times the parentheses, right? So we have to divide by 4.
That's tricky.
It is tricky. You got to pay attention because now we got all sorts of things going on here,
Yeah,
right?
and I was thinking, I don't know, for some reason I started thinking about like multiplying the 4 times the 2.
Distribute. You actually can do that. It just tends to make things longer. So we're just going to peel off the layers. You can do it,
Okay.
and you'll get the
okay,
right
I was
answer.
I was like, okay, I remember
Yep.
distributing like the 4.
Yeah, and we did that on the simplifying ones.
Okay.
And you can do that. It's just sometimes it'll make it longer.
Okay. Okay.
So if we're going to get rid of this multiplication, we've got to divide by 4, right? Okay. Now that 4 is going to cancel with that 4. And now what do we have left?
2x
2x
-6.
-6, right? That's what we have left. And we don't need the parentheses anymore because now that's all that's left. Equals, and this is a 4. And the nice thing is, once we do that first step, doesn't it look like what we were just doing?
Yeah.
Now what's grouped with the x?
2x.
The 2. And so we have to get rid of
The 6.
the 6. How do we get rid of the 6?
Add 6.
Add 6, because they're subtracting the 6. We need to add 6, cancel out, and we have 2x equals 10. And then our last step, how do we get rid of that 2?
Divide.
Divide by the 2. And that's the key thing with these equations. They can look crazy sometimes, but if you take one step at a time and just peel off one layer at a time, eventually you get down to stuff you've already done, right? So if we're okay at the 2-step, this is just one more step. At least this one was. Okay, and again, if we wanted to, we could go back and check 4 times the 2, and then I'm going to put a little parentheses here, times x minus 6 should equal 16. And we're going to put in that 5 that we just figured out down here. And let's go ahead and do that. Because remember, order of operations, we start on the inside and work out. Solving, we have to start peeling off the layers and work in. So we start with 2 times 5, and that is 10. And then 10 minus 6 is 4. And 4 times 4? Yay, we got the right answer, right? Okay. So again, you can always check. And if I was doing this, if I wanted to check it, I would just take this and type it into a calculator. And you should get your answer of 16. Make sure that your calculator is one of those that does the order of operations correctly, though, because otherwise some of them, again, do not do that. I think most of your guys's will. I'm not sure. Some of them I'm not as familiar with. The Casios I'm not as familiar with, but I know that one will. That's the same one. I think I worked with her the other day and hers did. So most of these will do. Most of them now do the order of operations correctly. Again, back in the day when I was in high school and college, I had one of those little tiny ones, and there was not even such a thing, I don't think, as a calculator that did the order of operations correctly at that time, but maybe there wasn't, whatever. Okay, 60, getting serious here. Where's our split? What separates the sides?
15.
The equal sign, right?
Yeah.
So the only thing we don't have to get rid of is the 15. We've got to get rid of the 3, the 2, the 4, and the 9. We've got 4 steps this time. Do you think we can do it?
Yeah.
I think you can do it. Okay? So again, let's kind of think about this. What is the very, very inside part that's grouped directly with the X? The 2. So this is the very inside part. That's the last thing we're going to touch. What's the next layer that's grouped with the
-4.
yeah, this part. Okay. Now, between the 3 and the 9, because that's all that we have left, right? Which one is grouped more with the X, the 3 or the 9?
3.
It is the 3. Okay, the 3 times that X stuff
Okay.
rather than the +9. The +9 is the further out one. So let's go with this color. That's supposed to be purple. It looks kind of dark like black, but anyway, whatever. Okay, so what does that mean we're going to get rid of first?
The 9.
The 9. The 9 is the outside layer that we're going to get rid of first. So how do we get rid of that 9? You're going to subtract 9, right? It says +9. We want to subtract 9. And we subtract 9 from both sides. That cancels. And I'm going to write all this stuff down. 3, parentheses, 2x minus 4, close my parentheses, equals, and this is going to be 6. Now, again, I want to reassure you because now doesn't this look almost exactly like the last example that we just did? Now there's 3 things to get rid of. Again, if we want to think about what's grouped together, that's the very, very inside layer. This is the next inside layer. So what are we going to get rid of next? The 3. How do we get rid of the 3? Divide, because this is times 3 times the parentheses. We are going to divide by 3. Okay. And the 3's will cancel out. And we have, now we don't need that parentheses anymore. Does that make sense why I don't need the parentheses anymore? Because there's nothing outside of the parentheses that it matters. We know that this is grouped together because that's all that there is. All right. And again, what are we going to get rid of next? The -4, right? Because the 2 is grouped with the X. That's the very, very inside layer. How do we get rid of the -4? Add 4. Add 4. So now this cancels out. And what we have left is the 2x. And we have a 6. And then what is our very last step here? Finally, we can get rid of the 2. How do we do that? Divide by 2. And we get x equals 3. 6 divided by 2 is 3. And again, if we want to go back and check, and I'm just going to, 2 times 3 is 6. 6 minus 4 is 2. 3 times 2 is 6 again. 6 plus 9 is 15, and it checks out. And again, you can use a calculator to check that pretty easily. Now, I realize that one got a little bit longer, right? That one was 1, 2, 3. That one was 4 steps. Are we okay with that one? Do we have any questions on it?
How would you check it on the calculator, like the X?
So if you were going to check it on the calculator, what you would do is you would just type in 3 parentheses, just like it says here, and then 2 times, and then you put in your number here. So let me switch colors. This is our answer. So in place of the X, we're going to put in the 3.
Oh, duh. Okay.
And then -4, close your parentheses, plus 9. And you just type all that in. And again, if your calculator does order of operations correctly, you should just be able to type all that in and hit enter or equals, and you get 15. Okay. So any questions on that one? Do you see how it's just one step at a time? Each step is something we've done before, but it gets scary the bigger it looks. it looks
It's
scarier
scary when you have to choose.
when you have to choose. That's why we want to identify what's the inside, and we want to kind of, I mean, eventually you're going to look at it and you're like, oh, I know. I have to get rid of the 9 first because that's the outside. And then I'm going to get rid of the 3. And then I'm going to get rid of, and then you start understanding it more easily. Okay, so here's something that's different. I don't think we've had any of these yet. What do you guys notice that's different this time compared to the other problems?
Yeah, on both sides.
You've got an X on the left-hand side and a right-hand side. So far, what I've been saying is we've got to get the X by itself, right? Now we've got 2 sets of X's. So that changes our first step. We've got to cancel out the X on one side so that there's only an X on the other side. Okay? So here's what we do. Now, have any of you ever carried anything? Okay, well, I know the answer to that is yes, right? So if I have a feather and I have to carry around a feather, and I have a cement block and I have to carry around a cement block, which one is the easier one to move? The feather, right? Because it's smaller. This is kind of how I approach a problem like this. I try to cancel out or get rid of or move the smaller one of the X's, okay? Because we want to deal with the X's first. So between these two, this one is the one I want to get rid of first. I'm going to cancel because the 4 is bigger than the 2. Does that make sense? Using the same rules we've been doing before, if I want to cancel out this whole thing, how would I cancel it out?
Negative 2x.
Subtract, right? We want to cancel it out to make it a 0. So we're going to subtract 2x from both sides of our equation. So subtract 2x and subtract 2x. And again, I should put my boundary in here so we keep that in mind.
Okay. So why? Okay. I guess I'm gonna say why would now we can do the X first.
Okay, so everything that we've done up to this point, there was only one X in the problem.
Yeah.
Right? So that's what has changed now. Now there's 2 X's in the problem. So our goal is to get only 1 X in the problem because then we know what to do. Okay?
Oh, okay. Good.
So if we can get rid of one of these X's, then there's only 1 X left.
Because on this side you see the answer.
You'll just have something else,
Yes.
and then all the X's are on one side, and that's what we want.
Okay. Now it makes
Does that make sense?
Okay.
So when you have 2x minus 2x, cancels out, right? Just like 5 minus 5?
So you wouldn't do the division here?
No, and that's the part you have to be careful of because we are completely canceling out. We want to turn it into a 0. Okay? And actually, if you tried to divide, dividing would make this really, really messy and bad things would happen. So you don't want to divide. Okay. Because again, our goal is to actually just get rid of that X. So to get rid of that X, we subtract it. If it's a positive 2x, we subtract 2x. If it was a negative 2x, we would add 2x. So that side cancels out. On the left-hand side, what is, and this goes back to last week, what is 4x minus 2x? Remember how that works?
4x minus 2x is 2x.
Yeah, you just work with the number. Remember, if the variables are the same, which they are, they're both x's, you just subtract the numbers. So 4 minus 2 is 2, and we still have the x, and then minus 6 equals, and that's gone, right?
10.
And this is 10. Hey, that's really nice because now this is two-step equation, right? So you've got that first step of getting the x's together, so there's only 1 x in the problem, and then the rest is just what we've been doing. So which one do we need to cancel out next?
Negative 6.
The negative 6 is the outside layer, right? And how do we cancel out that negative 6?
Plus 6.
Plus 6. And we add 6 to both sides. All right, so that's going to cancel. And what we have left is 2x equals, and we're adding, so that is 16. And what is our last step going to be? Divide by 2. Because this is multiplying, so we've got to divide. And this cancels. And then we have x. And we have 8. Now again, even though this looked different at the beginning, we can check our answer, right? Let me show you how you would do it. We would have 4 times, and I'm going to put the 8 in a different color, just so we remember that's what that is. And then it should equal 2 times x plus 10. And if we put in the 8s here, Okay, and you can, again, you can do that on your calculator. Just do one side, get the answer, and then do the other side. But I'm going to go ahead and do it because I don't have my calculator with me here. 4 times 8 is 32 minus 6, and 32 minus 6 is 26. So that's the left-hand side, and we're hoping they're equal. 2 times 8 is 16 plus 10, and 16 plus 10 is 26. Yes, we got the right answer. But this time you actually have to simplify on both sides to see if you've got the right answer. Okay, but yes, this is our answer. That's just checking. Okay. Remember, the only time you have to do that is if you have x's on both sides of your equation. Okay. Any questions on that one before we go on? Yeah.
First, how did you decide which X to cancel?
Okay, and that was my example of the feather and the brick,
Yeah.
or the brick.
Yes.
I just picked the smallest one.
Just pick the small.
Yeah, and the reason that I do that is because when I cancel out the smaller one, I know that the result is going to be a positive number.
Yeah.
You can cancel out the 4x. The difference would be then you'd have a negative 2x over here. And sometimes negatives confuse people. So I'm like, if you cancel out the smaller one, you never have to worry about that. It will
Yeah,
always
I
be
wish they
positive.
wouldn't have told us that in school. I don't think they did.
Well, and it's one of those
And
things.
they make it
You
really
you don't
hard.
have to do it that way,
But
but
it
I
makes
think it's
sense.
probably easier to do it that way. So, but does that make sense?
Yeah.
Okay, and that's just a personal preference. You
Mhm.
can do it the other way. It's not going to be wrong either way. It will still be right. It's just sometimes people get more confused by negatives than they do with positives.
Yeah, I do.
Okay, so it'd be a good option for you.
Yeah.
Huh? All right, so let's take a look at this one. And again, I must have been putting her to sleep. She had to stand up.
Oh, I got a back.
Oh, okay. We look at this one, and again, we have x's on both sides, right? X's on both sides. So looking at this, if we want to cancel one out, you've got a -3 and a 6. Which one is the smaller one?
-3.
The -3. Now be careful. How do we cancel out a -3x?
Plus 3x.
Plus 3x, right? Because we want to cancel it out to be 0. So plus 3x. Plus 3x. This cancels out. That was the goal. It cancels out to be a 0. Now we just have 9 over here, and we have 9x, and we have -27. So again, now we're down to a two-step equation. What are we going to get rid of next?
-27.
-27. How do we get rid of it?
Add 27.
Add 27. Correct. So this cancels. We have 9 plus 27 is 36. And equals 9x. And then how do we get rid of, well, what else do we have to get rid of and how?
9.
Get rid of the 9 and how? Divide, because it's multiplied, right? So to get rid of it, we divide. Divide by 9, divide by 9, and we get 4. Yeah, x equals 4. Okay. That makes sense? Easier the second time? That's what happens. You practice these and they get easier, right? Because you've done them before and
Give
you've
us some
seen
more.
it. Give you some more? All right. Okay. 1,000 of them. Okay. Oh, no. Getting serious here. Okay. Now, there's a lot going on here, right? So my suggestion is, in the last two, we had stuff on both sides, right? Or I should say we had x's on both sides. We had variables on both sides. But there wasn't any, if we go back, I couldn't combine the -3x and the 9, right? You can't put those together because they're, remember the term like, the definition like terms. We can't put them together because the variables are not the same. And the same thing over here. We can't put them together. Well, now that we get to this one, notice we have multiple x's on this left-hand side, right? I'm going to go ahead and draw our dividing line again. We've got multiple x's on the left-hand side, along with an x on the right-hand side. We can't do anything right now with we can't simplify the right-hand side. But this, if you just look at this side, this looks like some of the stuff we did last week, right? Where we could simplify it. And we're going to start out simplifying first until there's nothing else we can do on the left-hand side.
Okay.
Okay, so we're going to leave this alone. We're not going to touch the x plus 18. Just leave it there. We want to simplify this side. How would we start simplifying the left-hand side?
Like 2 times 1x.
Yeah, we're gonna get rid of these parentheses by distributing the distributive properties. So 2 times x is going to be 2x. And then remember, we have to do 2 times -5. And what will that be?
-10.
-10. And then plus 3x. Notice the 2 does not go all the way to the 3x because that's not in the parentheses. Okay. Then we have equals. And remember, we're not doing anything over here. We're just going to leave it alone. Okay. What else can we do to simplify on this left-hand side?
Okay, we had 3x plus 2x.
Correct. Like terms. These two can go together. What happens when you add 2x and 3x?
5x.
5x. X plus 18. Now, can we add the 5x and the -10 together?
No.
No. I want to pause here for a second because this is where my high school students, college algebra students, a lot of times people get mixed up right here. Because they're like, oh, I need to cancel. So I'm going to subtract the 3x here and here. I shouldn't even probably say that because I don't want to put it in your mind. We are not canceling anything out here. We are just simplifying this left-hand side. Does that make sense?
Mm-hmm.
If you're going to cancel, you have to cancel on both sides of the equation. You could do that once here, but then you'd have to do it over here. Once on both sides. Remember to keep the teeter-totter balance. If you do it on one side of the equation. But notice here, we're just combining these together. The 2x and the 3x equal the 5x. We're not changing anything. We're not canceling anything. We're just putting them together. Does that make sense?
Yes.
I know that's going to probably take some practice because that tends to be something that can be confusing to people. Okay, once we've simplified that left-hand side, this looks like the last two examples that we have just been doing, right? Where there's an x on both sides. So what do you think we should do next? Yeah, which one is the smaller one? The 1x. How do we get rid of it? How do we cancel it? Minus an x. Subtract the 1x. And I'm going to emphasize it is a 1x. You said 1x. That's what it is. So subtract the 1x over here. On this side, it just cancels. That was the goal. So all that's left over here is 18. Over here, 5x minus the 1x gives us 4x minus 10. And again, from here, we should be on relatively smooth sailing. What are we going to get rid of next?
10.
The -10. And how do we do it?
Plus 10.
Add 10. Okay. And then this cancels out. And we have 4x equals 28. And finally,
4 divided by 4.
divide by 4. And we get
7.
x equals 7. Okay, and if you wanted to check that one, you can. You just have to replace all the x's with 7s. Okay. I'm going to let you guys ponder that one for a second because I've got some people studying it very diligently and see if anybody has any questions.
Why did you get 1x on the
Where are we looking?
negative 1x?
Right here?
Yeah.
Okay, because this was, remember this automatically has a 1 in front of it, right? So if we want to cancel it,
Okay. Yes. Okay.
we're subtracting. Does that make sense? Okay. Any other questions? And really the key thing with any math pretty much is try not to be scared of it because people get scared of math. It's just numbers on a piece of paper. It can't be that scary, right?
Says the math teacher.
Oh, believe me, there have probably been times where I was, but honestly, if you think about something, even if you're playing a sport, if you are scared of the other team, are you going to probably play as well as you could? No, because you start getting anxious and panicking and things like that. You just got to relax. And if you get it wrong, honestly, it's not the end of the world if you get it probably
You're not
wrong.
gonna give me the points.
Well, that's true. But I have made mistakes and gotten things wrong in my life too. And I've been doing this for a lot of years.
So in high school,
math teacher should teach just only math. That's it.
Should?
That kind of do you teach?
That's
like,
what
two or
that's
three
all I
subjects?
teach. Yeah. In this school. I have taught other things. When I taught in Singapore, I taught math and science.
So what do you teach? Do the dual credit
That's college
College
algebra.
algebra?
Yep.
and then what else?
Oh, what else do I teach?
Yeah.
I teach college algebra. I teach algebra 2.
Mm.
I teach, what else do I teach? Advanced math, which is like between algebra 2 and calculus. I teach calculus also. So, yeah, that's what I get to deal with the older kids. I leave the younger kids for like Mrs. Willis and
I don't mind it.
Miss Geyer and Miss Asher and things like that. Okay, so any other questions on this one? Okay, so going on here, let's take a look at this one because this one's kind of similar, right?
Yeah.
Now, this one is actually
Easier?
a little bit easier because
You know,
notice there's only x's on one side.
Mhm.
Now, we still have to simplify, but there's no x on the other side. Okay, so how do we begin simplifying? Because here's our boundary. There's just a 5 over there. How do we begin simplifying the left-hand side?
Distribute.
Yeah, we're going to distribute. And notice we've got 2 sets of distribution, right? We're going to distribute the 3 right here, and we're going to distribute the 4 right there, the negative 4. So what do we get here?
12x.
Is that okay? 12x? That's correct. I just want to make sure everybody's on the same page.
I'll let the other one sometime.
The other ones? How about, what do we get here? Negative 15. Yep. Okay, now be careful. This one, we're actually distributing the negative 4. What do we get there?
Negative 8.
Negative 8x. So minus 8x. And then we distribute the negative 4 again to the 1, and what do we get there? Negative 4. And then equals 5. Okay? Now we're not ready to cancel anything because we can still combine, right? We can still simplify. This is what we did last week. So what can we combine? I've heard 12x. What can we combine the 12x with? The negative 8x. And when we add those two together, 12x plus a negative 8x is 4x. Correct. So that's combining those two. Then let's go with this. We've got a negative 15. Can we put anything with that? Negative 4. Those are both just constants. Remember, they're just numbers. And what do we get when we add those two together?
Negative 19.
Negative 19 is correct. Equals 5. And now, once again, we're down to a 2-step equation. Our second favorite. 1-step equations is our favorite, right? 2-step is okay. So what are we going to do next? Yeah, we've got to get rid of the 19. So we add 19. That's correct. And cancel to be a 0. And we have 4x equals 24. What else do we have to do? Divide by 4. So that means the 4's cancel out. We have 1x left over, and this would be 6. And so again, once we finally get the x by itself, then we're done. Okay. Any questions on that one? Am I okay to go on? All right. Bunch of words. Now, this is not something you have to memorize because this is just what we've been doing already. It's just kind of a summary. So this leads us to a 5-step process that we can use to solve any linear equation, and it's just what we've been doing. So first, distribute through any parentheses. If you've got some simplifying to do, you can do that. Okay. Combine like terms on each side, just like we were doing, right? Simplifying. Once you get everything simplified, then we want to get the variables on one side by adding or subtracting. So in other words, we cancel out the variable on one side, just like we did, right? When you have it on both sides, cancel one of them out. The fourth one, solve the remaining 2-step equation. Add or subtract, and then multiply or divide. So again, the layers. The addition and subtraction layers are the outside, the multiplication, division are the inside layer. And then finally, just like we've done a couple of times, didn't do it every time, but you could, check your answer by plugging it back in for the x to figure out if it's a true statement or not. Okay, and again, that's nothing you have to memorize. That's just what we've been doing. So if it helps you remember to kind of go through these steps, that's fine, but that's what we've been doing each time. Okay. All right, and that's already on your papers, right?
Yeah.
Okay. So a couple of special cases. So it looks complicated, right? And so let's see, where's my equal sign? Right here. Do we see that we've got some simplifying to do, right? Because of these parentheses and stuff. So let's start on the left-hand side and begin simplifying that. What would we do to start simplifying the left-hand side?
Multiply.
Distribute the 4, right?
Mhm.
So what do we get right here?
8.
8x. And what do we get right here?
28 negative.
Close.
24.
Oh,
24.
negative.
Yep. And then we still have the plus 9, right?
Mhm.
And then our equal sign. And then we've got some simplifying on the right-hand side also. What are we going to do there?
Multiply or distribute the 3.
Distribute the 3. So that gives us 3x. And then what do we get here?
Negative 21.
Negative 21. Okay. And then plus 8x. All right. Then what else can we simplify on this left-hand side?
Negative 24 plus 9.
Yeah, let me underline that because we're going to simplify this. So the 8x is just going to stay there, right? We're not doing anything with that. But negative 24 plus 9 is negative 15. All right. Then on the other side, I think I might have a typo in this, but anyway, let's find out. On the other side, what can we simplify on the other side?
3x and 8x.
3x and 8x. Okay. And when we combine those, what do we get? 11x. And then we have minus 21. Okay. Then, okay. Pause for a second, take a small break. I need to check something because I think I maybe copied this problem wrong, and I need to find out because I don't want to do it, and then because it doesn't look like a special case to me, and I want to double check.
I thought.
Yeah, you're gonna get an answer. Let me double check, and then I'll either know I'm right or know that I'm wrong. All right, this was section 1.3, right?
Mhm.
All right. See, I make mistakes sometimes. It just happens. I try not to, but sometimes I do. We'll find out if this is one of those times. This is four times 2x plus 3. Oh, I copied the wrong problem. Anyway, all right. This one is just kind of normal. This isn't a special case. I'm sorry. Okay, let me get back to my other screen here. All right, this was supposed to be a special case. The next one is a special case, and so we'll see what happens there. All right, so now we're down to this type of problem, and variables on both sides. What do we want to do?
Subtract 8.
Yeah, subtract the smaller one, right? 8 and 11. 8 is the smaller one, so let's subtract the 8x.
Gosh.
And again, there's no law that says you have to do the smaller one. I just think it's easier to do the smaller one.
The answer's gonna be the same.
The answer is going to be the same. Okay, so that is negative 15, and this becomes 3x and minus 21. Then what do we do after that? Because our goal, remember, x by itself.
Add 21.
Add 21 on both sides. I love to hear that on both sides because that makes us remember that we're keeping the teeter-totter balanced, right? So cancel this And this is now a 6 equals 3x. And
Divided
then
by 3.
divide by 3. And we get 2 equals x. Okay? And that's why it's not a special case, because we just get an answer, and that's not what was supposed to happen in the special case. So save that for the next slide. Okay? Are we okay with x equals 2? Does that make sense? All right. Then let's, does anybody need more time to write this down? I'll wait. Okay. Let's try this one, which looks pretty similar to that other one. All right. So, again, here's our boundary, right? Make sure you kind of keep that in mind. You don't have to draw lines or anything, but keep in mind where your boundary is. Is there simplifying that we can do on the left?
Yes.
Yes. Is there simplifying we can do on the right?
No.
No. So we're leaving the right-hand side alone, but we're going to simplify on the left. I'm just going to copy that one down. What can we do on the left-hand side? Distribute. So 2 times the 3x will give us 6x. 2 times the -5, -10, and then minus 4x equals. Is there any more simplifying we can do?
Yes.
Yes.
6x proportional. Negative
Combine them? Yep. So like terms, what do we get when we put those together?
2x.
2x. So 2x minus 10 equals 2x plus 7. Now here's where you're going to hopefully see this is weird, because what did we say we should do at this point? Cancel out the smaller one. What's the problem? They're the same. Now we are going to still cancel one of them out. So how do we cancel one of them out? Subtract 2x. But when we try to cancel one of them out, what happens on the other side? It cancels that out too. Notice there's no x left. How do we get the x by itself if there is no x? Can we get the x by itself if the x is gone? No. That's what makes this a special case. The x is gone. Now what we're left with is a statement. That statement is either a true statement or a false statement. In this case, does -10 equal 7?
No.
No, this is a false statement. What that means is, because the x's cancel out, it doesn't matter what you put in for the x's, they will cancel out. And you'll be left with something that is false, no matter what. Remember our goal. The solution is to figure out what can make the equation true. No matter what we put in, this is false. So that's why this is a special case. This is one. This is one where we have no solution.
The answer will be false.
The answer is there is no solution. Yeah.
Are we gonna ask somebody to
On the test?
yeah.
I
I don't know. It's okay.
haven't made the test. Have I made the test yet? I can't remember if I've made the test yet. It is,
Or the quiz,
I will
or-
say it is possible you could have this on the test. Okay. But I'm not going to say it's not on there because we are covering it for a reason. Okay. Because this can happen. Now, the other special case problem was supposed to do the same thing, only at the end, we would have got something like this. So cancel, 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 all the x's cancel, and we're left with this.
Oh, so it will be
A true statement. Now, what does that mean? It means no matter what you put in for x, it's going to be true. Does that make sense? Because all the x's are going to cancel out. It doesn't matter what you put in. You're going to be left with a true statement. Yeah, because 5 does equal 5. So in this case, this is the special case. We say all real numbers.
So then if you plug the 5 on the x, like on the equation, you're supposed to get, or you would do whatever number?
You could choose any number. You could put in a 10. You could choose a -3,000. You could choose 1/2. You could choose 100 trillion. It wouldn't matter. Whatever you put in, you will get a true statement. If this happens. You could choose those same numbers over here, and you'd never get a true statement. You could try every number in the world, it would never work.
I would have to put all real.
And it would take you forever to try all the numbers in the world because there are a lot of them. Okay, so those are the two special cases. I apologize that I messed up that one example because I was going to try and give you both of them, but this is what would have happened on the other one. You would have gotten a true statement, and that means all real numbers. So the solution is everything. Okay, and that's the end. If I ever teach this class again, I'll have to make sure I get that fixed so I don't look like a dork. Get everything on. Okay, so again, there are 9 questions on this one. This is obviously the longer one, right? Because these problems took a little bit longer.